Now let's take a look at solving absolute value equations. When you have absolute value symbols all by themselves, what you're going to do is split it. We're going to split that equation. One thing to make a note of down here is that you're always going to have two answers. Always two answers. So we're going to jump right into these equations. Alright, the instruction is going to be solve for x. Let's say absolute value of x equals 6. Okay, so kind of simplistic one here, but once you have the absolute values, these symbols right here, all by themselves on this side of the equal sign, we're going to go ahead and split the problem into two. You're going to write what's inside the absolute value on both sides. You can create two equations here. The equal sign, and then what you're going to do is take the number over here, write one is positive, one is negative. And what you've done here is now you've solved and got two answers. X equals positive 6 and x equals negative 6. You've got two answers. And if you don't believe me, the way to check your equations if you have the right answers is to take those answers and plug them back in. So let's take positive 6. If I take positive 6 and plug it back in here, positive 6, the absolute value, positive 6 would be 6. If I plug in negative 6, the absolute value of negative 6 is also positive 6. So we see that both of our answers work out. Let's go ahead and apply these to a little bit more complicated problems. Let's say the absolute value of x minus 4 plus 2 equals 14. So we think about this as an equation that we're trying to solve. We want to solve for x. I want to get x all by itself. The problem is that it is trapped inside these absolute value symbols. But I can't get to these absolute value symbols yet because if I look at it, there's my equal sign. I have the absolute values and then I have a plus 2. I can't get to the absolute value yet without moving that plus 2. And the way we move that to the other side is by subtracting 2. But what I do to one side of the equal sign, I need to do the other. So now I have absolute value of x minus 4 equals 14 minus 2 is a 12. Now the absolute values are ready to get played with. Once you have the absolute values and nothing else outside of it, we're ready to split this problem into two. We write what's inside. X minus 4 and x minus 4 equals and equals. And now we're going to take this 12, the number over here by itself, write once as positive, once as negative. And now if we look at it, we've got two equations that are very solvable, no absolute values anymore. And we're creating two answers. So solving on the left-hand side, add 4, x equals 16. There's my first answer. If I do it on the other side, again, I'm going to add 4, x is negative 8. So we've got two answers solved for x. And if you want, you can plug those answers back in, see if they come out to the original. And let's just check one of them. So 16 and negative 8. So if I plug in 16 here, 16 minus 4 is 12. Absolute value of 12 is 12, and 12 plus 2 is 14. Okay, that works out. The other number is negative 8. If I plug in negative 8 and a negative 4 make a negative 12, but then apply the absolute value. A negative 12 would come out as positive 12, and positive 12 plus this 2 comes out as a 14. So they do all work. You don't need to check them every single time, as long as you trust your work on it. Let's try another. Let's say the absolute value of 10x over 8 equals 3. Solve for x. Again, x is located up here inside absolute values. I can't get to that x yet, so let's look around it, see if there's other numbers we can move. The 10's still inside, so that's not it. Ooh, I need to do something with that 8. The 8 is connected to the absolute value with division. The opposite of division would be multiply. So if I multiply this side by 8, the 8's cancel. But what I do to one side, I need to do the other. So I still have absolute value of 10x equals 3 times 8 is 24. All right. Now the absolute value is on the left-hand side of the equal sign all by itself. I can't get in there yet, and the way we're going to break this apart is by splitting it into two equations. So I write what's inside. The 10x, write it twice, equals, and now I need to write the number, the 24, once as a positive, once as a negative. And now we've created two equations that are going to give us two answers that are both solvable. I want to get x by itself. We've got a 10 that's connected by multiplication, so we're going to divide it off. What I do to one side, I do the other. 10 doesn't go into 24 nicely, but it does simplify, it does reduce a little bit. Top and bottom reduced by 2, so that's going to leave me with a 12 over 5, and we're okay with that answer for right now. The x is by itself. Same thing for the other side, we're going to divide by 10. And the only thing that's going to be different this time is this 12 over 5 is going to be negative. But we still have two distinct answers, both of them that work when we plug them back in. All right, let's go ahead and make a little bit more complicated problems out of these. So for example, negative 2, absolute value 4 minus 9m equals negative 64. All right, so think about this. I want to get to the absolute values. I can't do that. I can't even get to the m until I've dealt with everything outside of it first. So deal with outside the absolute values. That would be the negative 2 that we're talking about. Now I've got to do the opposite of how it's connected to the rest of it. Not just because it's a negative 2, I'm not going to add. It's connected to the absolute value by multiplication. So the way we're going to actually get rid of it is by dividing by negative 2. That's the opposite there. It's the same thing as if it said negative 2x equals negative 64. The way you would get rid of that negative 2 is by dividing it. It's the same idea here. This x just represents the absolute value. But if I divide one side by negative 2, I need to divide the other side. So I still have 4 minus 9m. Negative 64 divided by negative 2, that's going to come out positive, and it's going to be a 32. And now there's nothing else outside the absolute value, so now I'm ready to split this into two problems. 4 minus 9m over here, 4 minus 9m over here, so that's the inside part, equals, this gets written once as positive, once as negative, and now we've got two equations that we need to solve. Alright, so we'll do the problem on the left first. I need to get m by itself. There's a 4 and a 9. The 4 is actually going to move first, and we're going to move it by subtraction. So we still have negative 9m equals 32 minus 4 is a 28. See, we moved the 4 because that's a little bit farther away from the m. We want to get closer and closer to it. Finally, last thing we're going to do is divide by that negative 9 because it's attached by multiplication. What I do to one side, I do the other. So m equals 28 over 9 doesn't really reduce at all. So what we're going to do is just leave that as a negative 28 over 9. M is by itself. We're okay with that. Let's go on the right hand side. It's actually going to be the same steps. Minus 4, minus 4. Negative 9m equals negative 32 and negative 4 make a negative 36. Take both sides, divided by that negative 9. Negative over negative is going to come over positive, and 36 divided by 9 is a 4. So this one came out nicely. But still, either way, we get two answers for these problems. Right. We'll try one last one. For example, 2 absolute value 7 plus 9x plus 7 equals 93. Okay. So again, I need to get to these absolute values. We have numbers outside of it. The 2 is attached by multiplication. The 7 is attached by addition. The weaker one is the 7. We're going to move the 7 first. And that's going to move by subtraction. So we still have 2 absolute values, 7 plus 9x equals 93 minus 7 comes out to an 86. All right. Next thing to do is break off this 2. That's going to break off with division on both sides. Absolute value 7 plus 9x equals 86 divided by 2 is a 43. All right. Now I notice my x is inside the absolute value. I can't get in there without breaking the absolute values off. And remember, the way we do that is by splitting the problem into 2. 7 plus 9x equals a positive 43. And on the other side, 7 plus 9x equals a negative 43. 2 solvable equations. Minus 7 on both sides, so 9x equals 43 minus 7 is a 36. Now divide by 9, x equals positive 4. On the other side, same steps, minus 7. 9x equals negative 50. Divide by 9 on both sides. Doesn't reduce, doesn't really simplify, so negative 50 over 9. So the thing to remember for this lesson is once you have those absolute value symbols all by themselves, what you want to do is split them. One with a positive answer, one with a negative answer, and then fully solve out the rest of it.